Okay, objective 67, example 3. While graphing with rational equations, y equals x over x plus 3. So just like the previous problems, our first step is to find the vertical asymptote. We'll set our denominator equal to 0 and solve. So x plus 3 equals 0. Solving this equation leaves us with a vertical asymptote at x equals negative 3. Now the horizontal asymptotes on this are different from the previous two examples. The numerator now has a degree of 1. The denominator has a degree of 1. So what we want to do is look at the coefficients of the terms with the highest degree, or the lead coefficient of the numerator and the denominator. The lead coefficient of the numerator is 1. The lead coefficient of the denominator is also 1. So the horizontal asymptote exists at the ratio of the numerator over the denominator. So basically y equals 1 over 1, which is 1. So our horizontal asymptote here is y equals 1. We'll draw our asymptotes in. Here's x is negative 3. And y equals positive 1. Now we can create our t-table for this. This is much easier than example 2. The first x value that's undefined is negative 3. That's the only x value that is undefined. The other values that we'll use here are negative 4, negative 5, negative 6, and negative 2, negative 1, 0. When x is negative 4, we get a value of 4. When x is negative 5, we get 2.5. When x is negative 6, we get 2. When x is negative 2, we get negative 2. When x is negative 1, we get negative 1/2. And when x is 0, we get 0. So here we go. 1, 2, 3, 4. We can go ahead and plot our curve. So there's the first curve and the second curve. Again, following our asymptotes as a general guideline. So the only part that was different about this was our horizontal asymptote, which again is the ratio of the lead coefficients on the terms with the same degree.